All right, you're all welcome to Maslows TV. My name is Evans. I'm still your mathematics facilitator. We are still on the concept of circle geometry. Yes, in our previous lesson, we dealt with the fourth theorem, but today we are combining the fifth and the sixth. Yes, we are almost done with the eight theorems I gave. All right, yes. So, as I said that after we are done going through all the eight basic theorems. We are going to take some questions, some past questions and examples and go through. All right. So those of you who have not yet followed me, kindly follow Mazris TV on YouTube. You can also get most of my videos on Facebook and then TikTok as well. So please kindly follow, like, and share the videos as well so that whenever I post new videos, you get the update. All right. So for the today's lesson, as I said, we are combining the fifth and the sixth. Yes, they all talks about what tangent from a point to a circle. Yes, that's why we are combining the two. Just that we have different principles here. So we are going to look at all of them. If that's the case, then let's look at what this theorem is talking about. Okay, yes, but before that, what is a tangent or tangent line at all? So when we talk of a tangent line, we are saying that it's a straight line that touches a curve or a circumference of a circle at one point. Yes, so we must touch the circumference of a circle at one given point. So if we are to take this curve, yes. So we realize that the line touches this point at A. Yes, that is the tangent line we are talking about. Okay, the straight line that touches that point at A is what the tangent line we are talking about. All right. So let's take this circle as well. Okay. Yes. So if we have this circle, then we can also get a tangent line at this point, but A. Yes, that is what we are dealing with. Okay, if that's the case, then let's look at the theorem itself. Okay, what does this say? So for the first one, we are seeing that this theorem shows that the length of two tangent lines from the circle that converge or meet a point, or yes, that converge or meet at a point are equal. Yes, so what we are trying to say is that if you have a circle, if you draw two lines, once those lines, uh, once they touch at one particular point at the circumference of a circle, if those two lines they meet or they intersect or they converge at a given point, then the length from their respective points on the circumference of the circle to that point where they intersect, their length are what equal. That's what we are trying to say. If that's the case, then let's look at this circle. Okay, so let's have this identify our center. Oh, good. So we can have one tangent line here which touches the circle at a point, and another one also here. You realize that these two tangent lines what converge or meet at what B. Okay, so from point C to B and from point A to B. Okay, so what it is trying to say is that so the length of CB is the same as what the length of AB. That is what it is trying to say. Okay, that's what you are saying. AB, length of AB is equal to length of what? BC. So that is this principle. Okay, yes. So let's look at the second one, the sixth one. What does that one also say? So for that one too, we are saying that the angle the tangent makes with the radius of the circle is equal to 90 degrees, or the angle between the radius and the tangent is right angle or 90 degrees. Yes, so that is what this theorem is also saying. Okay, yes. Yes, so what this is also trying to say is that remember uh, when we started, we looked at the part of a circle. We said that when you draw a line from the center to any point of the circumference, that line is what? The radius. So this one, what it is trying to say is that if we draw a line from the center to point C and also one from center to point A, then the angle, okay, that will form between uh, the radius and the tangent. At that point, the angle formed is what? Right angle or 90 degrees. So these are the angles we are talking about. Okay, so that portion where the angle is formed is what? 90 degrees. All right, so very, very simple. All right, yes, if that's the case, then we can see that uh, angle OAB is equal to angle OCB, which is 90 degrees. So take note of that. Okay. And then we can draw a line from the center to B that also divides it. Okay. If that's the case, then we can see that line OA is equal to, or the length of OA is equal to the length of OC, also equal to the length of what? OD. Yes, because they are all radius. So take note of that. All right. Yes, good. Now, you know that we can also, once we are saying that the angle formed at C and D is right angle, then we can use Pythagorean what? Theorem. You remember when we're dealing with Pythagoras theorem, we talked about this, the right angle triangle. Okay, the right angle triangle. How did we go about it? We use Pythagoras to find the other sides. Okay, yes, so here too we can use what? That is the length of OB squared is equal to the length of OC squared plus the length of what? BC squared. Or we can also get the length of OB squared is the same as what? The sum of the length of OA squared and the length of AB squared. Okay, so that is Pythagoras. All right. Yes, and you also know that each of the triangles, we can sum the interior angles of those triangles. Okay, so you could see that we have angle OAB plus angle ABO plus angle AOB, which gives 180 degrees. Have you gotten the point? Yes. So we can also get what? Angle what? OCB plus angle OBC plus angle COB, which also gives 180 degrees. So these are some of the basic principles about the tangent from a point to. Okay, we can get a lot of properties here. Okay, but these are few of them. All right. So what we are going to do is now is that we shall take example and look at how we can go through. But before that, let's switch back to our software. That is the GeoGebra software. That is what we have been using for this concept. Okay, it has been helping us to prove all these theorems. So we are going to use it to prove that these theorems are true. All right. Yes, that is great. Okay, good. All right. So this is our GeoGebra software. Okay. So we are going to prove that theorem. All right. Yes. So before that, let's try and drag this. Let's drag it here a little bit. Okay, so that we can get full space for our circle. All right. Yes, that is good. Good. Okay. So I will draw my circle. So I'll click here. Okay. Then I'll draw my circle. I'll drag it. Okay. To any size I like. So I'll draw it like this. I want to move it small. Okay. So I will come here. All right. Yes. Good. Now I want to draw the tangent line. So before that, I have to create a point outside the circle. So I'll click here, choose point. Then I will make a point somewhere here. Okay. Yes. So I have point C. Okay, yes. So once I have point C, then I'll come here, click here, and select what tangent. Okay, because I want to get two tangent lines. Okay, so what I will do is I will click C. Okay, I'll click C, then touch any point at the circumference of the circle where it will touch. Okay, so let me click here. So you see that now it has created. Okay, yes. So once it is created, then I want to make the point where the lines would touch at the circumference of the circle. So let's say we have this point here as D, and then we also have this one here as E. Okay, yes, so that is what we have. So we want to know whether indeed the length of CD is the same as the length of what CE, as the theorem suggests. Okay, so what I will do is I will come here, then select what distance or length. Okay, then I will click C and move to D. So I have CD as what? 5.81. Let me try and see if I will get the same from C to E. Okay, then I'll move to E. So perfect. So from C to E2, we are getting the same thing. So that one has also proven. Now let's look at the angle, whether we get the 90 degrees of the right angle. So first of all, I will draw a line segment from the center A, okay, to D, okay, to D. Then the same from A to E. Yes, so I have created this as well. Now we are going to check whether we are going to get the right angle there. So here I will select angle, okay, and then I'll move anti-clockwise direction. So I will step here, A, and then come to D, okay, then move to C. Good, perfect. So you see that we have 90 degrees there. Then I will also come to, so I will click C again. Then I will come to E, click E, then move to A. Good. And that one has also given me 90 right angle. So you see that it's very, very well. True. It is true. Yes. So GeoGebra has helped us. Okay. Let me move the angles so that you see them uh, well. Okay. So this is 90. Okay. And this is also 90. So these ones are very basic. All right, GeoGebra has helped us. Now, if that's the case, then let's go back to our question. I said we have one question that we need to solve, try, so that in case we meet them in the question, we know how to go about it. All right. Yes, that is good. Okay. Yes, so we have this question. Now this is the diagram. Okay. Yes, so we have to find the value of x and also angle OCB, the length of CD and the length of OB. Okay, so for this one, let's look at it. Okay, so for the first question, which we have to find x, okay, you know that if we have this, if we consider angle triangle AOB, AOB, you realize that we have angle OAB giving us what 90 degrees. That is what the theorem talks about. Okay, the angle between the radius and the tangent. Okay, the angle from there is 90 degrees. So if we have it there, remember O we have for triangle AOB, and we can add the interior angles of that triangle. So if that's the case, we can add them, which should be equal to what, or which should give us 180 degrees. If that's the case, then we are going to have 90 plus 30 plus x, which is equal to 180. Then we add as we go to 120 plus x is equal to 180. Okay, then we group like terms, and then x is going to give us 60 degrees. Okay, yes, and that is the answer for the first question. Now let's look at, so you see that it's very very easy. Let's look at the second one. So we are to find OCB, OCB. And as I said, you know that that one, that point also gives what, right angle. So it is also what, 90 degrees. So the question 2 is also answered. Then we move on to the 3. We have to find the length of CD. The length of CD. So we know that the principle is saying that C line, the length of what, CB should be equal to the length of AB. So if we have the length of AB as 9 centimeters, then we can conclude that the length of AB is length of CB. And what is length of CB? How do you get that? It's length of CB should be equal to the length of CD plus the length of what, DB. Once we are given DB as 6, we don't know CD, so we can substitute our values and then group like terms. Okay, so we group like terms, and then we find CD as what, 3 centimeters. Yes, 3 centimeters. So very very simple. Okay, very very simple. Then we look at the last one, which is OB. We are asked to find OB. Now here we can use Pythagoras theorem. Remember, once we have a right angle triangle and we have the length, two of the lengths are given, we know that OA is what, 5 centimeters. We can do that. All right. Yes. Then, or maybe we can also use the trigonometry. Once we have one angle there, that is the x, which is 60 degrees, we also have 30 degrees. We can even use that one to solve, but let's use Pythagoras theorem. Then we can say that OB squared is equal to OA squared plus AB squared. And if we substitute our values, we are going to have OB squared is equal to 5 squared plus 9 squared, and that is going to give us the square root, or maybe yes, we add them first, and it's going to give us what, OB is going to be what, the square root of 106, and that will give us what, 6 root 3 centimeters, or we can get decimals, which we may get 10 points, I think. Yes, some digits. Okay, so that answers everything. Very very simple. All right, so that is all about our concept today. Okay, so let's end here and continue next time. When we meet next time, we are going to look at the rest of the theorems. Okay, yeah, so before I go, let me introduce myself one last more. My name is Evans. This is Mazvis TV. Kindly subscribe to my YouTube channel, like and share. You can also get Mazvis TV on TikTok and Facebook as well. So see you next time. Bye bye.